If you want to understand why some infections keep coming back, no matter how many antibiotics you take, don't look at the bacteria themselves. Look at the invisible protective shield they build that makes them almost impossible to kill. Hi, I'm Dr. Liana. I'm an emergency medicine physician and infectious disease researcher. And what I'm about to share with you challenges everything most people believe about chronic infections. Here's a number that should stop you cold. Up to 80% of all chronic and recurrent infections are caused not by normal free-floating bacteria, but by biofilm-protected bacterial colonies that can resist antibiotic treatment up to 1,000 times more effectively than ordinary bacteria. That means the sinus infection that keeps returning every few months, the urinary tract infection that never fully clears, the gut issues that won't resolve, they're not happening because you're unlucky or because you need stronger antibiotics. They're happening because the bacteria have built an impenetrable fortress that conventional medicine doesn't know how to break through. In this video, I'm going to show you the exact mechanism by which one specific yellow spice that costs less than $5 disrupts bacterial biofilms at the molecular level, exposes hidden infections your immune system couldn't reach, and eliminates chronic bacterial problems that have resisted every other treatment you've tried. Most people have been told that recurrent infections mean they have a weak immune system or that they simply need longer courses of antibiotics or stronger medications. Take the pills, finish the prescription, hope it doesn't come back. That's the standard playbook. But after nearly 15 years practicing emergency medicine and studying infectious disease mechanisms, I've observed something that completely contradicts that simplistic advice. I've watched patients cycle through antibiotic after antibiotic for chronic sinus infections, urinary tract infections, small intestinal bacterial overgrowth, skin infections that keep returning to the exact same location. The cultures show the bacteria are sensitive to the antibiotics. The labs say the treatment should work. But 3 weeks after finishing the medication, the infection is back. For years, that pattern was frustrating and unexplainable. Doctors would blame patient compliance or suggest the immune system was compromised. But the real answer is far more sophisticated and honestly more disturbing. Think of bacterial biofilms like a city protected by a fortress wall. Inside that wall, bacteria live in organized communities, sharing nutrients, communicating through chemical signals, and collectively building an extracellular matrix, a slimy protective shield made of sugars, proteins, and DNA that acts like bulletproof glass around the colony. Your immune system can see the infection. It sends white blood cells to attack. But those immune cells can't penetrate the biofilm barrier. Antibiotics flood your bloodstream at concentrations that would easily kill free-floating bacteria. But inside the biofilm, bacteria are protected, dormant, waiting for the antibiotic pressure to disappear so they can emerge and recolonize. This is not theoretical biology. Biofilms form on medical devices like catheters and joint replacements. They grow on heart valves, causing endocarditis. They colonize the lining of your sinuses, your bladder wall, your intestinal tract, your lungs in chronic respiratory infections. And once established, these biofilm communities become nearly impossible to eradicate with conventional antibiotics alone. The standard medical approach completely fails to address this mechanism. Doctors prescribe antibiotics that kill the small population of free-floating bacteria, temporarily reducing symptoms. But the biofilm-protected reservoir remains untouched, and within days or weeks, bacteria emerge from the biofilm, recolonize the tissue, and the infection returns. This cycle repeats indefinitely because the root cause, the biofilm itself, is never disrupted. Now here's where it gets fascinating and completely unexpected. One specific yellow spice that's been used in traditional medicine for over 4,000 years contains a compound that does something no conventional antibiotic can do. It doesn't just kill bacteria, it actively breaks down the structural matrix of biofilms, exposing the protected bacterial colonies to your immune system and to any antimicrobial compounds present in your body. And the one food at the center of all of it, most Western doctors will never mention it: turmeric. Specifically, the active compound curcumin found in turmeric root. Before I explain the science, I want to address the obvious skepticism because I would share it. The wellness industry has spent years marketing turmeric as a cure-all remedy for everything from joint pain to cancer, which has understandably caused a lot of people to dismiss it as pseudoscience or wishful thinking. But the research on curcumin and biofilm disruption is not testimonial. It is peer-reviewed, mechanistic, reproducible, and increasingly well-documented in clinical microbiology journals. Let me walk you through the specific studies that convinced me this wasn't just cultural folklore, but a legitimate antimicrobial strategy supported by rigorous science. Researchers at the University of Texas Health Science Center studied the effects of curcumin on Pseudomonas aeruginosa biofilms, one of the most antibiotic-resistant and biofilm-forming bacterial species responsible for chronic lung infections in cystic fibrosis patients and severe hospital-acquired infections. They exposed established biofilms to curcumin at concentrations achievable through high-dose supplementation and measured biofilm mass reduction using crystal violet staining assays, the gold standard laboratory method for quantifying biofilm density. The results showed curcumin reduced biofilm formation by 73% and disrupted existing mature biofilms by 61% at concentrations of 50 micrograms per milliliter. That's not folklore. That's measured laboratory data, showing this compound physically breaks apart the protective matrix bacteria hide behind. But Pseudomonas is just one species. What about the bacteria that cause the infections most people actually struggle with? A landmark study from Banaras Hindu University in India examined curcumin's effects on Staphylococcus aureus and methicillin-resistant Staphylococcus aureus, MRSA, the superbug responsible for skin infections, bloodstream infections, and post-surgical complications that resist multiple antibiotics. Researchers grew MRSA biofilms on medical-grade surfaces and treated them with curcumin alone, conventional antibiotics alone, or the combination of both. Curcumin alone reduced biofilm viability by 55%. When combined with antibiotics that normally couldn't penetrate the biofilm, curcumin increased antibiotic effectiveness by over 400%, turning previously resistant infections into treatable ones. Think about what that means. The antibiotic that failed when bacteria were protected inside the biofilm suddenly became lethal when curcumin broke down the protective barrier first. Now, let's talk about the infections that impact millions of people every single year and send them cycling through doctors' offices over and over. Urinary tract infections. Researchers at Pusan National University in South Korea investigated curcumin's effects on uropathogenic E. coli, the bacteria responsible for over 80% of urinary tract infections, particularly recurrent UTIs in women. They found curcumin at concentrations of 100 micrograms per milliliter inhibited biofilm formation by 89% and disrupted preformed biofilms by 72%. Even more importantly, curcumin specifically targeted the fimbrial adhesins, the tiny hair-like projections bacteria used to attach to bladder walls and initiate biofilm formation in the first place. By blocking bacterial adhesion, curcumin prevented the infection from ever establishing the protective biofilm architecture. This is the difference between surface-level symptom management and addressing the actual mechanism that makes infections chronic and recurrent. So, how does curcumin actually accomplish this at the molecular level? What is happening inside that biofilm when curcumin molecules make contact? Mechanism 1: extracellular matrix degradation through quorum sensing disruption. Bacteria inside biofilms don't act as individuals. They communicate using chemical signaling molecules called autoinducers in a process known as quorum sensing. When bacterial population density reaches a critical threshold, these chemical signals trigger coordinated gene expression that tells the colony to start producing the extracellular matrix components, the sugars and proteins that form the biofilm shield. It's like a construction crew receiving the order to start building the fortress wall. Curcumin interferes with this communication system. Specifically, it inhibits the LuxS enzyme and the autoinducer 2 signaling pathway that many gram-negative bacteria use for quorum sensing coordination. When curcumin disrupts these signals, bacteria fail to receive the instruction to build the biofilm matrix. The chemical command never arrives, so the fortress never gets built. Think of quorum sensing like a radio frequency bacteria use to coordinate group behavior. Curcumin essentially jams that frequency. Individual bacteria can still survive, but they can't organize into the protected biofilm architecture that makes them so resistant to treatment. They remain vulnerable, exposed, easy targets for your immune system and any antimicrobial compounds present. Researchers at Cairo University documented this mechanism in Salmonella biofilms, showing curcumin downregulated the expression of genes involved in biofilm matrix production by 68% compared to untreated controls. The bacteria were still alive, but incapable of forming the protective structure. Mechanism 2. Direct enzymatic degradation of the biofilm matrix. Even when biofilms are already established and mature, curcumin can break them apart through direct chemical interaction with the matrix components themselves. The biofilm matrix is made primarily of extracellular polymeric substances, complex sugars called exopolysaccharides, proteins, and extracellular DNA that bacteria excrete to build the protective structure. Curcumin possesses chemical properties that allow it to bind to these molecules and destabilize their structural integrity. Specifically, curcumin chelates metal ions like calcium and magnesium that act as cross-linking bridges holding the matrix together. Imagine the biofilm matrix like a chain-link fence where metal posts connect the wires. Curcumin removes those metal posts, and the entire structure collapses. Additionally, curcumin exhibits proteolytic activity, meaning it can break down the protein components of the biofilm matrix directly. A study published in the Journal of Applied Microbiology demonstrated that curcumin treatment reduced the total protein content of Streptococcus mutans biofilms, the bacteria responsible for dental plaque and cavities, by 49% after just 24 hours of exposure. What this means practically is that curcumin doesn't just prevent new biofilms from forming. It actively dismantles existing mature biofilms that may have been protecting chronic infections for months or years. It's the difference between preventing a wall from being built and actually tearing down a wall that's already standing. Mechanism 3. Synergistic potentiation of antimicrobial activity. This is where the research gets truly remarkable. Curcumin doesn't just disrupt biofilms. It fundamentally changes how bacteria respond to other antimicrobial compounds, including conventional antibiotics, immune system defenses, and natural antimicrobial substances your body already produces. Multiple studies have documented this synergistic effect. Researchers at Süleyman Demirel University in Turkey tested curcumin in combination with commonly prescribed antibiotics against biofilm-forming strains of Staphylococcus epidermidis, a bacteria that colonizes medical implants and causes difficult-to-treat device-related infections. When antibiotics were used alone against biofilm-protected bacteria, they achieved minimal killing. But when curcumin was added first to disrupt the biofilm, followed by antibiotic treatment, bacterial killing increased by over 300%. The mechanism behind this synergy operates on multiple levels. First, by breaking down the physical biofilm barrier, curcumin allows antibiotics to penetrate to the bacterial cells underneath, increasing effective drug concentration at the site of infection. Second, curcumin inhibits bacterial efflux pumps, the molecular machinery bacteria use to pump antibiotics back out of their cells before the drugs can do damage. By blocking these pumps, curcumin traps antibiotics inside bacterial cells, dramatically increasing their lethal effectiveness. Third, And this is particularly important for people dealing with antibiotic-resistant infections. Curcumin has been shown to reverse antibiotic resistance mechanisms. Bacteria develop resistance through genetic mutations that change drug target sites or produce enzymes that destroy antibiotics. Curcumin downregulates the expression of these resistance genes, essentially turning resistant bacteria back into susceptible ones. Think of it like this. The biofilm is the fortress wall. Efflux pumps are the emergency exits bacteria use to escape when antibiotics get inside. Resistance genes are the body armor bacteria wear, even if the antibiotic reaches them. Curcumin tears down the wall, locks the exits, and removes the armor all at the same time. Suddenly, bacteria that were untouchable become completely vulnerable. Mechanism 4: immunomodulation and enhanced host defense activation. Your immune system is perfectly capable of clearing bacterial infections under normal circumstances. The problem with biofilm-protected infections is that immune cells can't reach the bacteria to kill them. Curcumin addresses this in two ways. First, by disrupting the biofilm structure, curcumin exposes hidden bacteria to circulating immune cells. Neutrophils and macrophages that were previously blocked by the biofilm barrier can now make direct contact with bacterial cells and destroy them through phagocytosis and oxidative killing mechanisms. Second, curcumin directly enhances immune cell function. Research from the University of Michigan demonstrated that curcumin increases the expression of antimicrobial peptides like cathelicidin and beta-defensins that your immune system uses as natural antibiotics. These peptides punch holes in bacterial membranes, causing cell death. Curcumin essentially tells your immune system to produce more ammunition and then removes the barrier that was preventing that ammunition from reaching its target. A study in the journal Nutrients followed 62 patients with recurrent urinary tract infections who supplemented with curcumin extract at 500 milligrams twice daily for 12 weeks. Researchers measured immune markers and infection recurrence rates. The curcumin group showed a 47% reduction in infection recurrence compared to the control group, along with significantly elevated levels of antimicrobial peptides in urine samples, confirming the immune enhancement mechanism was active in human patients, not just laboratory cultures. Now, let me give you the exact protocol based on what the research tells us. The critical factor is not just consuming turmeric powder in your curry or adding a pinch to your smoothie. The biofilm disrupting effects require achieving therapeutic concentrations of curcumin in your bloodstream and at the site of infection. Standard turmeric powder contains only about 3% curcumin by weight, and curcumin has notoriously poor bioavailability, meaning most of it passes through your digestive system without being absorbed. Here is the precise protocol supported by clinical evidence. Take 500 milligrams of curcumin extract, standardized to 95% curcuminoids twice daily with meals. This dosing matches the concentrations used in human clinical trials that demonstrated antimicrobial and biofilm disrupting effects. Critical preparation detail: curcumin absorption increases by 2,000% when consumed with piperine, the active compound in black pepper. Every curcumin dose must include 5 milligrams of piperine or 1/8 teaspoon of black pepper. Additionally, curcumin is fat-soluble, meaning it requires dietary fat for absorption. Take your curcumin with a fat-containing meal or add 1 teaspoon of coconut oil or olive oil to ensure maximum uptake. Timing matters significantly. For chronic infections, take 1 dose in the morning with breakfast and 1 dose in the evening with dinner, maintaining consistent blood levels throughout the day. For acute infections, or when supporting antibiotic treatment, some practitioners recommend 3 doses of 500 milligrams, spaced 8 hours apart, to maintain continuous biofilm disrupting pressure. From clinical practice, here are the 4 critical details that make the difference between partial results and complete biofilm elimination. First, consistency over intensity. Biofilms don't disintegrate overnight. The research shows measurable biofilm reduction begins within 48 to 72 hours, but complete disruption of established mature biofilms requires sustained curcumin exposure over 14 to 21 days. Sporadic dosing won't work. You need continuous molecular pressure on that biofilm structure, day after day. Second, hydration amplification. Curcumin works by physically accessing the biofilm site. Adequate hydration ensures optimal blood flow to tissues, delivering curcumin molecules to the infection location. Drink at least 8 full glasses of water daily, more if you have urinary tract involvement, where flushing mechanisms support bacterial clearance. Third, probiotic protection. As curcumin disrupts pathogenic biofilms, it can also affect beneficial bacterial communities in your gut. Supplement with a high-quality multi-strain probiotic containing at least 20 billion CFUs taken 2 hours away from curcumin doses to maintain healthy microbiome balance. Fourth, expected healing response. When biofilms break apart, they release bacteria, toxins, and inflammatory debris into surrounding tissues. Some people experience a temporary worsening of symptoms in the first 3 to 5 days as the immune system clears this material. This is not treatment failure. This is the biofilm dissolving, and your body eliminating the infection it can finally reach. Symptoms typically improve significantly by day 7. Now, let me tell you the 5 mistakes that undermine this protocol and prevent people from seeing the results this research promises. Mistake 1: using low-potency turmeric powder instead of concentrated curcumin extract. Turmeric powder from your spice cabinet contains roughly 3% curcumin. To get 500 milligrams of curcumin from powder, you would need to consume over 15 grams of turmeric, which is not practical or palatable. You need a standardized extract. Mistake 2: taking curcumin without piperine or fat. Curcumin by itself has bioavailability of less than 1%. Without piperine to block metabolic breakdown, and without fat to facilitate absorption, you're wasting your money on curcumin that never enters your bloodstream. Mistake 3: stopping too early when symptoms improve. Symptom resolution doesn't mean biofilm eradication. Bacteria can remain dormant inside partially disrupted biofilms, and stopping treatment prematurely allows them to rebuild the protective structure. Complete the full 21-day protocol even after you feel better. Mistake 4: ignoring underlying biofilm-promoting factors. High sugar intake feeds biofilm formation by providing bacteria with abundant glucose to build extracellular matrix. Chronic stress suppresses immune function, allowing biofilms to establish more easily. Address these factors simultaneously for comprehensive results. Mistake 5: using curcumin as monotherapy for serious infections requiring antibiotics. Curcumin is extraordinarily effective at disrupting biofilms and potentiating antimicrobial activity, but severe infections require professional medical treatment. Use curcumin as a powerful adjunct to appropriate medical care, not as a replacement. Let's lock in everything we covered so you can implement this starting today. Chronic recurrent infections persist not because bacteria are inherently untreatable, but because they build protective biofilm fortresses that shield them from antibiotics and immune attack. Up to 80% of chronic infections involve biofilms. Curcumin, the active compound in turmeric, disrupts biofilms through 4 distinct mechanisms: blocking quorum-sensing communication, degrading the extracellular matrix directly, potentiating antibiotic effectiveness by 300 to 400%, and enhancing your immune system's antimicrobial capacity. The clinical protocol requires 500 milligrams of standardized curcumin extract taken twice daily with 5 milligrams of piperine and dietary fat for maximum absorption. Effects begin within 72 hours with complete biofilm disruption, requiring 14 to 21 days of consistent use. Maintain hydration, protect your microbiome with probiotics, and complete the full protocol even after symptom improvement. Here's what I need you to understand. Your recurring sinus infections, your chronic UTIs, your persistent gut issues, they are not a life sentence. They are not evidence of a broken immune system. They are the predictable result of a biological mechanism, biofilm protection, that conventional medicine routinely fails to address. But you now have access to a compound that targets that exact mechanism with precision that rivals or exceeds anything pharmaceutical science has developed. This is not about replacing medical care. This is about addressing the gap in conventional treatment that allows infections to become chronic in the first place. These biofilms exist in your body right now if you've been cycling through recurring infections. The bacteria are hiding behind their protective shield, waiting for the next opportunity to cause symptoms. You can dismantle that shield starting tomorrow morning with a supplement that costs less than $20. Your health is not predetermined by bad luck or weak immunity. You have far more control than you've been led to believe. The question is simply whether you give your body the molecular tools it needs to access and eliminate infections that have been protected and untouchable until now. I see messages from people who've watched several of my videos and didn't realize they weren't subscribed. Could you double check right now? It's free, takes 2 seconds, and it helps this channel reach more people like you who want real science-based health information, not filtered through pharmaceutical industry priorities. If this information was useful to you, please share this video with someone you care about who's been struggling with infections that keep coming back. They deserve to know there's a mechanistic explanation and a research-supported solution. In my next video, I'm breaking down the second most overlooked cause of chronic inflammation, one that has nothing to do with diet and everything to do with a hidden infection almost everyone over 40 carries without knowing it. Dr. Liana out.